Hello and welcome to part 4 of predicting the stock market using Twitter. In the last video, we were able to train the Bert classifier in order to give us a fairly high accuracy for determining the sentiment of tweets, whether they were positive, neutral, or negative. And now we're going to take that one step further. We're going to download some actual stock data. We're going to take some tweets that go along with them for a period of 3 to 4 months. And we're going to see whether or not we can predict whether stocks will go up or down and try to turn that into some sort of trading algorithm to see when we should and shouldn't be investing in the stocks. So let's jump over to the Jupyter Notebook and we will continue where we left off. All right, we have Jupyter open. Now, this next part, now that we have the BERT model trained, we're no longer going to use that same data set. We're actually going to start looking at some real tweets over a longer period of time. So this website, follow the hashtag right here, has some data sets that people use for research. I was having trouble actually getting the data set from them. Their server was down when I was doing it, so if they are down, there's an alternative, which is from Data World. Someone has actually downloaded it, put it up there. But basically what it is, it's NASDAQ 100, so 100 stocks from the NASDAQ for a period of about 3 to 4 months. So it's a nice chunk of data of a whole bunch of tweets and a whole bunch of metadata associated with those tweets as well. So go ahead and download that from either of these links. You're going to get a zip file. Within that zip file, you're going to get a folder with a whole bunch of zip files for each of the different stocks. I have put all of that in a folder called data. As you can see, I have all of these stocks in here. And then within these folders, don't worry about the CSVs yet. We'll get to those. But you'll have each of these different Excel files. Now, the one main Excel file that we're going to be using is the dashboard. That's where the actual content of the tweets is coming from. So go ahead, take the time to download from either of these links. I'll throw them in the chat in the description as well. But go ahead, download those, extract all of the Excel files, and we can begin. So as you can probably tell, let me close this. I am right under where we trained our model. Now, if you are following this and you've just trained your model, you can go ahead and just continue on from there. If not, we are going to need to read in the model. So what I'm going to do is I'm going to scroll back up to the top where we defined our class for the BERT classifier. And I'm going to copy this and bring this down to the bottom. Now, I'm going to do this for those who do not have the trained models saved in memory right now. So I am going to, I'm going to restart my kernel just to show you that you can do this without having it already trained above. I'm going to start importing stuff. So I'm going to import OS, I'm going to import pandas, I'm going to import NumPy, I'm going to import Torch, I'm going to import preprocess. That's the script that I made in Python. You can get that from the GitHub page in the previous videos. I'm going to need to import torch.nn as nn. Looking through here, I think that is everything I need, but all right, I do need to import the BERT model as well. Let me go back up to the top where I started importing all of these. I'm just going to copy all of this right here. That's probably the easiest way to do it. Everything that we imported from the last video, I'm just going to drag down to the bottom. Or you can just actually rerun that cell. That will work easier. I'm going to rerun this cell first. And scroll back down to the bottom. The only one that's not in there is OS, I believe. And so we're going to import OS there. Okay. Now, if you want to define the model, what you need to do is you can just say model equals BERT classifier model dot load state dict. So we're going to do a torch dot load. And we're going to load whatever you named your model. So I named it stock sediment model.pt. The last thing we need to do is we need to figure out if you are using GPU or not, and then cast it to a GPU. So what we did the last time was let me scroll down, if torch.cuda.is underscore available. Then we're going to say device is equal to torch.device CUDA. And if you don't have a GPU, we're going to say else device equals torch.device CPU. And the last thing we need to do is say model.toDevice. Run that, see if we get any errors. Okay, it's just printing out the information for the model. We don't need to worry about that right now. And now we can get into actually using some of that data. So let me look at one of the data. So I'm going to say stock is equal to pd.read CSV. We're going to be looking for, I store this in data. One thing before this, I need to know what the file names are. So I'm going to say files is equal to os.list directory. So list dir, sorry. And I want to know everything in data. I'm just going to print files. Okay, so we have all of these files. We're looking at this one. Maybe we'll grab the first one. So we're going to say plus files at 0. This is going to grab the first file. And then that is going to get us into the folder. Now we need to actually grab the file. So it's going to be, the one we want, again, is, if I go back to opening one of these, let me open American Airlines. We want export dashboard. So it's going to be / export dashboard. And then we're going to add files at 0 to that. And this will make the name export dashboard with all of this .xlxs. All right. The other thing that I just realized I don't want is we are not reading a CSV. We're reading an Excel. So Pandas has read Excel. And this will read the entire, this will read the first sheet of the notebook, but the first sheet is not actually what we want. So we need to change the sheet name to be equal to stream. Now let me display stock. Okay, we have our stock displayed. You can see tweet ID, date, hour, username, whole bunch of other stuff. Now, the thing that we really care about is the tweet content. That is where the meat of the actual tweet lies. Other things that could be useful are the number of favorites, retweets. There's a couple other things within there that we will try to extract out and weight some of this a little bit. Other things like the amount of followers that the user has or the amount of people that are following them. Okay, so let's see. This is how we print the stock out. Now, what we're going to do is we're going to go through one by one each of these different files. So I'm going to make a for loop. So for x in range length of files, we're going to do this. Now, for the time being, just for testing, I don't want to read all of them. So I'm just going to say only the very first file by indexing it like this. We're going to make a new name called file name, and that's going to be equal to files at 0. And now instead of in here when we read it from files at 0, oh, sorry, this is not files at 0, this is files at x. Now in here, we can just pass in file name and pass in file name in here as well. Just going to run that and make sure we haven't broken anything, but we shouldn't. Okay, now it is up and ready to go. All right, now that I'm gonna get rid of this display for now. Now that we've read in the stock, we can add some things into it. So for instance, since the file name has the ticker in it, there is no column for the ticker symbol. So we're gonna say stock at ticker is going to be equal to file name dot split. We're going to be splitting on the underscore, and the reason we're doing that is because if I open this again, the actual file name was the ticker underscore and then whatever the year was and the date. So we're just going to grab the very first one, which was the ticker, and that is going to assign ticker a column within the data frame. Another thing is, if you scroll down, we have this date column, but right now these dates are stored as strings. So we need to convert those into actual dates. So stock at date is going to be equal to pd.to date time. And we're going to pass in stock at date. Now another thing, we have the date as one column and the hour as a second. I would really like to keep those together. So let's convert this to a date time. In order to do that, we need to convert the hours. So hour is going to be equal to, we're going to have to do a function here to extract each of the different pieces of the hour column. So we're going to say is equal to stock at hour dot apply. We're going to apply a lambda function, and we're just going to call this t for time, I guess. We're going to say pd dot time delta. The reason I'm doing time delta is I'm about to add this to the date, so I don't want it to be another date time. So time delta, we're going to say hours is equal to integer of t. So this is going to be the first two characters. And then minutes is going to be equal to the integer of t. This is going to be the last two. So we can say from -2 on. Okay, and this should give us our hour in terms of a time delta. So now we can say stock at date time. It's going to be equal to the stock at date plus the stock at hour. No, I'm just going to display stock to see what this looks like, make sure everything looks good. Okay, let me scroll over. And you can see we now have a date time that has the year with the hour and minute after. Okay, that takes care of the date time. Now, if you remember back from pre-processing the data in the last couple of videos, we needed the data frame to have a column called text. And right now, our column is called, if I can scroll over again, our column is called tweet content. So we need to rename that. So I'm going to say stock.rename columns. Columns is going to be equal to tweet content. And we're going to, since this is a dictionary, it's going to be asking what is it changing into, and it's going to be equal to text. And I'm going to say in place equals true. This should be a squiggly bracket. Okay, so this is going to rename the tweet content to text. Now we can go ahead and do that pre-processing step. So we're going to say stock is equal to preprocess dot preprocess tweets, pass in stock, and run it. Okay. Now we can see if I scroll over, we now have text clean in here as well that has converted the tweets into a nice clean format. One other thing, some of these data sets can be fairly big, especially like Apple has something like 160,000 tweets or something within it, and the whole data set together has over 1 million tweets. So some of these functions may take a while to process. So just be aware of that. Okay, so we have our clean text, we have everything we need, but we have a lot of excess columns that we don't really care about. Or I at least don't care about for the time being. So I'm gonna say I'm gonna redefine the data set to be only the columns I care about. So I'm gonna say I want the tweet ID, I want the ticker, date time would be helpful. I want the text of the tweet, so that's the uncleaned text. I also want the cleaned text. I'd like to know any favorites, any retweets. Scroll down a little bit. Retweets, I'd like to know how many followers the person has, and maybe the following. And one other one is a retweet, is also a, this should be capital I. That also possibly could be useful. We'll see if we're going to use it or not. But if I realize, you're just going to see it's a smaller data frame just because I'm not taking all these extra columns that take up a lot of space. Okay. And as you can see, it now fits on my screen. Now, there are a lot of nada numbers, and this is when the person hasn't had their post favorited or wasn't retweeted or anything like that. So I have done some work ahead of time, so I know that only the favorites, retweets, followers, and following are the ones that have no missing or have the missing values. So I'm going to say stock equals stock.fillNA. We're just going to fill it with 0 because that means nobody liked the post or favorited it or retweeted it or whatever it may be. And that will take care of all of those nada numbers. Okay. Now that we have that, we need to start doing the pre-processing for Bert. Now, if I scroll back up to the top, we have this function here called pre-processing for Bert. And we have to take all of this right here and bring it down to our function. So I'm going to put it right after the Bert classifier. And we do need to define a max length. So I'm going to say, I believe 53 was what we had up top. So I'm going to define that as well. And we should be good. So now we're going to tokenize all of the tweets that we just processed. So if you remember, it's going to give you inputs and masks. So inputs, masks is equal to pre-processing for Bert stock at text cleaned dot values. Okay, so we're passing in all of the clean text into the Bert encoder, and it's going to give us the inputs and the masks. I'm going to run this to make sure that we didn't forget anything. Again, this may take a while because we're trying to encode a lot of values right now, but there we go. We did not hit an error, so we should be good to go. I'm going to scroll back up again to right here where we have our data, our sampler, and our data loader. I'm also going to take the batch size because we're going to be keeping that. So go ahead and copy all of this where we created the data loader and bring that down to the bottom. Okay. Instead of train, I'm just going to call this stock, I guess. Okay. Instead of train inputs, we have stock inputs. That's what we have just imported up at the top. Stock masks, we do not have labels, so we do not pass this one in. We're going to be passing stock data here, and the stock sampler here. And now from this point on, it's just the same that we did for evaluating our model. So from evaluate model down, we're just going to grab everything up to preds. Come back down here right after we have our data loader. We're going to switch the model to evaluate. We don't need to track the loss or the accuracy because we don't have anything to test against because this is real data. Now we have a batch in the stock data loader. So we're going to go through each of the batches within this. We have the inputs, we have the masks, we do not have the labels. So we do not need the labels here either. Now we're going to figure out what the outputs were by passing in the inputs and the masks. We are not going to be doing the loss function, so you can get rid of everything with the loss. We do have our predictions, and we're going to convert those into zeros and ones. And then we are going to, we're going to say dot flatten in order to put this back to one dimension. And then we're going to say predictions dot append preds. So we're going to be storing the predictions throughout the batch and then looking at them at the very end. So right here before the batch, make a list for predictions. This is going to store all the predictions. Once the predictions are done, we can say predictions. So after the batch, we can say predictions is equal to torch.cat. So this is going to concatenate all the predictions. I'm going to cast it to CPU because I want to make it a NumPy array. So I can do .numpy. And now what I'm going to do is I'm going to make another column within the stock. This is going to be our sediment equals predictions. So now we are using the model to make the predictions. Once we get all the predictions, we're adding it into the data frame. And now we're just going to save the data frame. So I'm going to say stock.toCSV. And I'm actually going to come up here and where I read it in. So the data, file name, export dashboard, file name again. I'm going to copy that. And I'm going to paste it down here. So we're going to keep the data, file name, and instead of this last part, we're going to say this is going to be called stock data sediment .csv. I'm also going to say index equals false because I don't want it to pass in the index as a new column. And I am just going to say, before I do this, let me print out, I'm going to comment out the toCSV. I'm just going to display the stock just to make sure that our sediment is there and it looks the way it should be before I start running this. But the last thing we're going to do is just print out whatever file name was complete. So I'm going to say print out file name. I'm going to do .split on the underscore, and I'm going to take the 0. So that's going to give me the ticker symbol. I'm going to say dash complete. That way I can track as these are finishing which ones have been checked off. Okay, so this is, I guess, going to take a while. American Airlines doesn't have relatively all that many tweets compared to something like Apple, which has almost a tenth of the tweets. So hopefully this will complete fairly quickly. But this is going to save a file in each of those folders for whatever the sentiment is. And then after that, we're going to take all of the outputs and we're going to put them together in order to kind of predict over time what things are going up and what things are going down. So once this completes, what we're going to do is come back up to the top and we're going to take off only doing the first one. And we're going to do every single file and it's going to save all of the data for us. Now, having run this before, okay, now we have this, before I get to that thought, yep, now we have this, so we can see whenever there's a 1, it's positive, whenever there's a 0, it's negative, and it has been putting that in there. So that looks perfect. We can, I'm going to comment out display because I don't want to display it every time, but I'm going to comment in or put back in the to CSV, so we're just going to save this every single time. And then I am going to take off this range. So now we're going to do every single file, and it's going to save every single file into our folder. This, you have to do something like 103 files, and again, a lot of it's over a million tweets. So this is going to take a long time. It probably will take an hour or 2 hours for you to get through it. If you're on GPU, if you're on CPU, I don't know how long it's going to take. So definitely be aware of that and have some patience when you're doing this. It looks like this is working, so I'm actually going to stop here, and we're going to be using everything that we output here in the next video. So now that we have all the sentiment for all of these stocks, now is when we can actually start looking at how do they compare to the actual price day to day of the stock, and when can we use it to actually make predictions. So I will see you in the next video. I hope the code runs well for you, and we will pick this back up when we start working in the next video. So see you then, and thanks for joining.